And
Oh, yes. First off, I should probably do we're going to have a sprint on uni down at some point, and I think just this week it came out quite well.
that's right.
Yes, I don't know, I can't find the link. Nope, not at all. Hold on, Firefox. Yeah, so either this Thursday or Friday came out quite well. My personal preference, Thursday would be quite good, but put the link here in case anyone in here hasn't filled it in yet. So I'll just try and sort that out tomorrow. I'll send out some stuff about that tomorrow or this evening or something. Anyone got anything in particular they want? Oh, I released 0.6.2 earlier today, although I haven't built the content packages for it yet.
Yep, thank you.
Stealth release, yeah. Stealth release. Because I haven't, yes, the content package builders have decided they're going to die, so I've got to rebuild, I've got to remake all the content packages and stuff, so I don't know how I'm going to do that. Or more accurately, I don't know when I'm going to do that. But there is 0.6.2 on SunPy. Does anyone may want to talk about, or should we talk about the ordnance PR a little bit?
I have 3 outstanding PRs which require somebody else's +1. So they're all kind of on maps and map cubes. Also, like Mike's PR has this really weird error where you get like the same error repeats thousands of times, and then the continuous integration just shuts it off. Has anyone come across that before?
Yeah, I have no idea about that. That's really strange. I'm going to try and I should have a look at it at some point and try and remake it or something.
I've never seen that before. No. So your stable release has got a red X next to it?
Yeah, it's just quantified code.
Oh, right, okay.
Get Davy to turn that thing off, it's very irritating.
155 issues, wow. Quantified code.
On your decimal Carrington rotation PR, Jack?
Yeah.
do we need two versions of the same function?
I don't know. I mean, all this stuff should be. There's a more accurate way of getting the Carrington number, or at least when a new Carrington rotation starts, which is accurate to within a couple of minutes. It's a completely different piece of code. And the reason I put in the decimal Carrington was like it seemed like the existing Carrington number was like it's not clearly defined. It just said Carrington number, but I wasn't exactly sure what it was meant to be. Like the Carrington rotation
You actually call the old one.
Yeah, but then I just add in like I add in the L naught value. I think that's I identified that as the difference between the two.
Yeah, I don't know. Okay, I see. I hadn't noticed it was doing that before. It just seems somewhat confusing from a user perspective to have two things that are effectively doing the same thing, especially when one's calling the other. I mean, that's especially in Ruby. I mean, is the character rotation number that is only defined for the zero line of altitude, right?
Isn't it?
Do we need?
I thought the character rotation was defined as an average across the entire disk.
I don't know. It just seems somewhat crazy to have two functions that are doing the same thing, basically, or at least.
Well, they're not doing the same thing, though.
Well, no, but all right, but appear to be doing something relatively similar. Like, what is actually the difference, apart from accuracy?
Let's see, I forget about this now.
Because I think coordinates is using the one that was there already.
Yeah. Well, I mean, this PR I think is kind of stuck, in the sense that I like the decimal Carrington rotation number seems to be. Like you want the decimal Carrington rotation number is like a translation of time, right?
Yeah, I agree with that. The Carrington rotation number is more of a measure of time than actual location because it's all defined off of time.
It seemed like the existing one in SunPy was missing like if I'm right, then the Carrington that Carrington line moves across the sun, right?
Yep.
And then when it gets to the edge, then you get a new one.
Yep.
And so the Carrington longitude should be where that line is, right? Where the
yeah,
is that right?
It's 100% based on time because they just pegged a rotation rate, a mean rotation rate at a certain time, and then just tick off that rotation rate once every cycle. So it's all based on time. There's no actual physical measurement that goes into a Carrington rotation. It's all just a timing thing.
Coordinates actually uses heliographic solar center, which is stupidly named, just saying.
Why not leave that Carrington PR, because I think I need to understand it a little bit more. This all came out of, I asked the HelioViewer developer to translate some SunPy code to JavaScript to put Carrington numbers in SunPy, and they were out by hours, which is not acceptable. So there is something wrong with the Carrington rotation number, and whether we need two of them with like slightly more accurate definitions, or I just replace one with the other. I don't know. I don't work with Carrington numbers that often, so. And for the application I had in mind, I really only wanted to know when the Carrington, the next Carrington rotation started. So if anyone else has got anything to add, then like the Carrington rotation number in SunPy is not. I don't think it's well defined.
I know that the Carrington rotation rate in SolarSoft is split up between the integer rotation number and then the decimal beyond that, so you can request just the integer, you can request the integer plus the decimal, and which, I don't know, always seemed a little hokey to me, but I understand why they do it, because sometimes you just need a vague idea of the Carrington rotation number, and sometimes you actually do want it down to the 9th or 10th decimal place or something like that.
Yeah, so just call the one function and then round it down anyway.
Yeah, well, yeah, but clearly there is a need for both the coarse and fine definition of Carrington rotation number that you don't want to. I don't know. I guess it doesn't really matter passing high precision numbers back and forth anymore. So.
Yeah, if you're caring about performance so much that you want to pass integers around as opposed to floats, then you're using the wrong language.
Oh, yeah.
Okay, well, I mean, you need to find someone else to review those pull requests, Jack.
Yeah. I suppose I could just, can't I just game the system and have a whole extra GitHub identity, which some kind of mysterious up guy who gives me +1s all the time?
Just call it Reviewer 2.
I can't believe this is coded so well.
That's not normally what Reviewer 2 says.
All right.
So what were you Jed's talking about with the coordinate stuff earlier?
Well, coordinates. We haven't got any examples of transformations yet. Well, to see if the transformations hold up. But we'll get those.
Needs
Yeah,
some kind of analytical test as opposed to comparing to someone else's implementation, really.
you think?
Yeah. Yeah, I do.
So if we were to pass in some dates and times and well, what else is there?
Yeah, I don't know. But just going.
You don't want to compare
going
to SSW?
this. Well, we should, but going. Well, this bit of code doesn't give the same answer. Is well true, but is that bit of code right? Like.
Also, it should be pretty easy to assess the equal area projections, for example. And you could always, we could come up with a way of literally remapping a known coordinate system between the different projections to make sure that they all map in the same way. So I don't know. That's how I always checked my code, was that make sure it was reversible.
So this isn't doing anything with projection.
Oh, it isn't?
No, this is not doing anything with WCS, like WCS projection at all. That's handled by AstroPy WCS.
Oh, okay.
This is just converting between helioprojective Cartesian, helioprojective radial, heliocentric, heliographic, and heliographic Carrington. So it's all physical coordinates.
Right, okay, okay.
So what do you
all
want
the
to
like
test?
pixel data to coordinate stuff is done in map using AstroPy WCS.
Gotcha.
So what would you like to test then? Just the like cos 90 equals 0 or something like that, or what?
Well, that's the thing, right? In theory, I've just implemented the equations and, like, assuming there's nothing wrong with the equations that right. But it would be nice to have some kind of, I don't know, test case of this. I'll have to think about it. I've been thinking about it for a while. But there is a series of hooks that hook this framework in with the AstroPy WCS one, allowing you to go from pixel coordinates to sky coord. It is briefly documented, but that is the bit I haven't really worked on yet. I've kind of done it enough to make WCS axes work, basically. But as for like location and stuff, I haven't done anything. All that you basically what it does at the moment is takes the three parameters needed to describe the position of the observer in what is, to all intents and purposes, heliographic coordinates.
The position of the observer.
Yeah. So you have to specify the position of the observer yourself.
Yeah. Okay. Yeah, I didn't understand that, as you probably inferred from the questions. So this coordinates is just setting up the coordinate transformations, but not any projections onto the disk, into physics, into what the sun actually does. It's just.
So this does the physical coordinate systems, i.e. observer-centric or solar-centric coordinate systems in 2D or 3D space. not really always 3D space. Just assuming R is infinity, or 1, depending on how you fancy it. But it doesn't deal with imaging, like projection onto CCDs or anything like that.
Right.
It doesn't do FITS WCS. That's handled by SunPy. And this will take a coordinate location in helioprojective Cartesian and transform it into heliographic on disk coordinates for you.
So is the best way to think about this as just like do away with the sun entirely and just think of like I'm in some kind of theoretical space there's just a ball there, and how do I describe things in a ball? There's no notion of motion or where the observer is or anything like that. That comes in the WCS, right?
No, the coordinate is aware of, right, okay, so you've got one coordinate system is helioprojective Cartesian, right, where your observer is at the center of the coordinate system, the origin of the coordinate system. It's helioprojective Cartesian is a spherical coordinate system where your observer's at the middle and the sun, the center of the solar disk, is at the 0 line of longitude and latitude in the spherical coordinate system. That's helioprojective Cartesian, right? That's the standard imaging coordinate system that you get like AAA data in and stuff. What this does is take something in that coordinate system and transforms it into like on disk latitude and longitude. So to do that transformation, you have to know where the observer is with respect to the center of the sun.
Right. I think my question about that was if you know where your observer is and you know where what you're imaging, how is that different than what the WCS package is doing? I guess I'm confused on what is WCS and what this one is, where the separation between the two is.
WCS maps from pixel coordinates,
right,
array coordinates, to physical coordinates, as defined by the FITS header normally.
Gotcha. Yes.
Right? Whereas this goes from one physical coordinate system to another physical coordinate system.
Okay. All right.
Right, thanks, Stuart. That makes things a bit clearer for me. And that I would say that those notions are not clear in SSW, or at least have not been clear to me in SSW.
So at the moment, the way that it's rigged up is map does the conversion from data to pixel, like array coordinates to physical coordinates. It's terrible nomenclature, it really needs changing. Then this is a representation of physical coordinate systems. So, like, in the future, if you have a map and you go, I would like the physical coordinate at this pixel, please, it would return you one of these objects, which you could then transform into another system.
Alright, so like from map, then I would use WCS.
You'd use like map pixel to data, like we've got at the moment.
Yeah.
A pixel to data, you give it a pixel coordinate, and then it would return you one of these. And then you could convert that into heliographic longitude and latitude if that's what you'd rather.
Okay, and all that object that you get back would have the observer's position and the point you were interested in.
Yeah, assuming it's specified in the map metadata.
Yeah.
So it's if you get one of if you were to get one of these out of map, it would use the default values out of map, because I think map does guess like distance to Earth if it's not specified. It assumes
Yes.
Earth, right? Whereas this doesn't assume anything,
Okay.
which was kind of a deliberate design decision because
No, that's smart.
yeah.
Okay. Do we have a version of map with this?
No, I haven't done that yet.
No.
In theory, it shouldn't be particularly large changes, but I want to get it in separately first and worry about integrating it afterwards.
So everything that would come out would be, like, for example, if you had the physical extent of the image you were looking at, that would be a pair of sky coordinates.
If you've got well, maybe not like the length, because the length should really be in like degrees, right? I don't know. I'd have to think about that.
Yeah, what I'm worried about is that you would change API, right? Like if you want to, instead of returning just like a quantity, then getting a sky coordinate out. Is that?
If you're returning a actual coordinate, then it should return one of these. Like a length, like the extent of a box in, like this box is 100 arc seconds wide, isn't a coordinate, it's just a thing.
Okay.
I mean, yes, it is 100 arc seconds wide in some coordinate system. It's not quite the same thing.
Yeah, no, I get that.
So would this require the latitude and longitude on the face of the Earth for all ground-based observatories to be known? Because that's not necessarily listed in the FITS header of any ground-based solar images.
I don't know, right? Because when you're in ground-based, you're not really observing in the same coordinate system, right?
Right.
If you just assumed Earth, it would be easy enough. There is AstroPy coordinates has like transformations from like ground-based or adds into Astro frames. So we might be able to hijack into some of that machinery in some point in the future, but it doesn't go that far.
Okay. I just think that would make a lot of sense, especially with DKIST coming out with data at some point in the near, not too far future, that there's an easy way to integrate space-based and ground-based. I mean, it's built in kind of into the framework of whatever coordinate transforms you're doing.
Yeah, there's no reason why that shouldn't be possible.
Okay.
I'm looking into like hooking this into all of the AstroPy coordinate frames. So in theory, you should be able to transform to and from any given system in AstroPy, of which there are many. Quite how we go about doing that, I don't know yet. I need to. It's on the to-do list, but it's going to be a little while yet.
No, I
But at
thought
the
it was
moment,
cool.
this just handles the transformations between the common solar physics frames.
Oh, so it's not hooked into the full AstroPy machinery.
It is hooked into the AstroPy machinery, but there's no link between one of the solar frames and one of the AstroPy frames, right? So all of the individual frames, which are the coordinate systems, like helioprojective Cartesian is a frame. We haven't defined a transformation between one of our systems and one of the AstroPy systems. So you can't have a coordinate in one of the solar frames and transform it into ICRS in AstroPy, for instance, because that mathematics hasn't been defined.
Oh, and
So is that where this coordinate package is going? Is that the future direction of this coordinate package, or is that something entirely different? Is that an entirely different project?
That's the idea. I think I've worked out how to define a transformation between probably heliographic and ICRS. But I don't know how useful it would be at the moment. Although I did find out that AstroPy has some machinery for very accurately calculating the position of the Earth in ICRS coordinates. So if we
Yes.
could transform that out of ICRS and into like heliographic coordinates, that would be exceedingly useful for us. And I know like Stereo HI has ICRS in the WCS headers as well as HPC.
Yeah.
But I don't know how. Like, so there are some uses for being able to do that transformation. Probably, don't know. We'll have to see.
So you want some examples of just the pure, just testing the coordinate transformations. Let's leave the WCS out, but then that's that.
Yeah, so the coordinate transformations are mathematically defined in Bills-Thompson's paper, right? They're
Presumably you have tests for that as well.
At the moment, I only have tests that that compare the results to the previous SunPy implementation. I haven't added like any accuracy tests or anything to the transformations yet.
Okay.
That's one of the things that's missing, but it doesn't necessarily need to block this. Right? That's one of the other reasons why I haven't like integrated it into anything yet, because it needs a bit more validation before we start using it for everything. Although saying that, of course, we're using the stuff that's in SunPy.wcs at the moment, which probably hasn't been validated in the same way we're going to do with this. But obviously that's not a reason to not do it. It's just... If you feel any of like these questions, the documentation needs improving, you should give me some suggestions on what bits to expand in the docs.
Yeah.
This is, as they stand at the moment, they're like kind of beta, right? Because I haven't got full narrative documentation and I haven't got accuracy tests and stuff, but they're still really useful. Like WCS axes. WCS axes has like the AstroPy coordinate system stuff baked into it, so you can do flipping incredible things with plotting and this framework. It's beautiful.
Okay. Well, you do have a couple of. There's a couple of accuracy tests.
There's a lot of tests, but as I say, the actual tests that like check the results of the transformations are just comparing them to the output of SunPy WCS, which, by the way, is terribly named. It's conflated.
What would you prefer it called?
Well, SunPy.wcs does do some WCS, like actual WCS, right? Pixel to data coordinate transformations, as well as the physical coordinate transformations. So it does both.
I see. Right. You shouldn't.
Well, I mean, one
It should be pulled apart, right?
Well, then the nomenclature gets a little strange if you combine them together. They are similar, don't get me wrong, but WCS is technically, WCS is technically the system defined in FITS headers to transform between array coordinates and world coordinates.
Okay.
What were you saying about doing multiple observer or like multiple viewpoint stuff?
Yeah, I mean, what I've been doing is trying to find a location on the sun with stereo, AIA, ground-based imaging, and so both stereo spacecraft, AIA, and then a ground-based H alpha imager. So that's where I don't know, where my research lies right now, which is being able to co-define a point in 3 different viewpoints that I'm confident is the same place on the sun.
Did you have a look at that GIST that I posted in the comment?
Yeah, I think that will definitely help. I'm just concerned about having to hack in some Gong data because I don't think there's support for Gong on SunPy yet.
Well, I think, yeah, I mean, it depends how much coordinate information is provided in those files.
Yeah, and that's a little bit iffy because the standards, especially for ground-based stuff, has been really, it haven't been as consistent as space-based headers. So
yeah.
it's a little bit of a crapshoot.
Yeah, this doesn't. So yeah, if you can get your Gong data in like a well-defined helioprojective frame, then this will do the rest. But you've got to be able to get that. You've got to be able to do the pixel to HPC conversion first.
Right, and there's the rub, right? It's
yeah.
to make sure that I have it well defined to put into the coordinate system. Yeah. No, but
I'll help you with that, Mike. That's
sure.
You write a little.
It's
what,
on a to-do list.
What coordinate information do you have in the Gong header? Like, is it in HPC, just inaccurate, or is it in something else entirely?
I mean, you do have the what is it? P angle, the B angle, the the time, and so all of those are kind of are fairly well defined, and then the location you are on the Earth. So from there's IDL programs to just do all the appropriate translations, and it's just making sure that that they're correct. And again, I have no validation for them. I just assume that they're correct. But then this would be a nice time to actually validate them.
I don't know how much difference being at different locations on the Earth actually makes.
I mean, it depends on what you're doing, really. So, I mean, not a terrible amount, but if you're talking about the Gong network, you're all quite close to the equator, so it's really not that bad. However, if you're comparing something like, I don't know, let's say a balloon mission in the Arctic compared to a view on the equator, that could actually have something to do. So that could change things. So.
I know that I don't know how.
There is AstroPy does have an example of calculating, I think, where some object is in the sky, and they have like an Earth location capability.
Yeah,
there.
it deals with as an Earth location.
Yeah.
But
we don't have I mean, the gold we don't have. If we could get the orbital location of SDO, for example, presumably we could put that into. Into this framework. We're going to have to do that anyway for stereo, but the difference between.
The orbital location of both SDO and stereo is given in the FITS header, right?
Yes, you're right. Yeah, it's already there. Yeah.
So yeah, there is the as horizontal coordinate system frame. For dealing with ground-based observations. I mean, crikey, it even calculates refraction shift and everything. That's mental. I mean, you could get out from that into some kind of space, into some sky coordinate. Probably ICRS would be the most useful, but or maybe not actually. You can't currently transform that into something sane. If you could convert that into some kind of geocentric. What the hell is a heliocentric true ecliptic? What is that? Heliocentric ecliptic coordinates. These origins. The origin of these coordinates are the center of the sun, the x-axis pointing in the direction of the true equinox, as at the time specified by the equinox attribute, and the xy plane, and the plane of the ecliptic for that date. Mental. Yeah, I don't know, trying to work out exactly how to hook in where to hook into AstroPy coordinates is really complicated. Because their coordinate systems are way more complicated than ours, most of the time. Yeah, I'll have a look. It's on my to-do list when I'm around a lot of AstroPy people at Python and Astronomy. I have to see whether I can make this work. But I don't know. I'd have to have a look at the gong data and try and work it out. Because it should be possible, but how easy it is, I don't know.
I was actually, for the coordinate validation, I wonder if it would work to pull a data set of like the transit of Venus, where everybody had figured out where exactly Venus was, and so there are several independent measurements of where Venus was, and then you can play with your heart's content to just, I don't know, find out where that dark disk was on the sun. So that's a really well-defined point on the sun. Might be worth trying.
Yeah, it's an interesting idea, especially for the full stack stuff. I mean, in theory, what's implemented in this pull request is actually really simple, right? It's just the mathematics out of the Bill Thompson paper. It's getting into one of these frames in the first place that is generally the challenging part, especially for ground-based data.
All right.
But yeah, please do have a play with it.
I was trying it earlier, so it looks really promising. Shall we move on to something else? We're near the end of the hour.
Have you got anything else in particular?
Well, I was going to ask about the Open Astronomy submission.
Well, that happened.
So thank you. You and David put that in?
Yeah, a bit of help from other people, AstroPy and YT people.
I saw David had a question about the whether it wasn't clear from the rules if all the sub-projects are going to get...
Yeah, in theory, well, by the strictest interpretation of the Google rules, Open Astronomy as a whole would get 2 students.
Who else is in there? Who else is in?
Us, AstroPy, YT, and Julia Astro applied this year.
Julia Astro.
Indeed.
What's YT?
So I mean, YT is like simulation data, generally astrophysical simulation data.
Okay.
I've used it. I used it for my PhD, but the MHD simulations and stuff. We find out on the 29th.
Well, last year we got rejected, right? But still went with Python. Is that still an option?
Yeah, yeah. We'll jump back to the PSF if and when we inevitably get rejected again. Unless it's fourth time lucky this year, of course.
And do you remember what the grounds were for the rejection? Just like too small a community, or
just lots of applicants, and you've got to draw the line somewhere is normally the thing that comes back.
Right. Well, fingers crossed. And this will give some cash, right, for me? Am I right? The Open Astronomy
yes, if Open Astronomy got in, we would get 500 US a student. That's what the Python Software Foundation gets in previous years. The mentoring organization gets 500 US a student.
Okay. That's all I've got. I don't have any more questions or anything else to say.
If I don't know whether anybody's got any experience on trying to interpolate a 3D grid of data, but if they do, I could really do with their help on it. On trying to create a resample of the map 3D class that I'm using in my project.
No. So does grid data, that doesn't extend up to 3D? SunPy grid data?
It does, but I can't seem to get it working. So I got to it. I'm just too novice at using the SciPy library. It's coming up with a weird error, suggesting that my positions are not in ascending order or descending order, when they quite clearly are, as far as I know. So it potentially is just a refinement that I don't fully know, and I can't see any examples online.
I've come across there can be issues sometimes with using the cubic versus linear interpolation. That can cause errors. That doesn't sound like that can cause crashes, I should say. But that doesn't sound like a problem.
Okay. Yeah, no, I'm not getting a crash or anything. I mean, it seems to be quite clear that I'm just not using the function correctly, but I can see millions of examples of them using it on a 2D and 1D array, but NumPy array, but nothing in 3D, sadly. So I have no kind of reference to work from. So it's worth me shouting out and just asking.
Yeah. Sorry.
Nice. Right, well, I will put together some material regarding the sprint. I assume everyone's responses in the Doodle poll still holds. We'll probably go with Thursday. Do you want to see whether you can cobble together some people in a room that got object?
I will try, but those guys, Stephen and Albert, super busy. We don't have time for fripperies like SunPy. So, no, or maybe they do. Maybe they want to relax
nice
with SunPy.
Break. Yeah, exactly. Yeah, a little bit of a mental holiday. Think about something else for an afternoon.
Busman's holiday.
Yeah, or a morning, preferably for you.
Yep.
But yeah, that's where we're going. It would be really good to make some serious headway on Uni Down.
Yes.
It needs to go away. It needs to be finished already.
These two, I think, coordinates and Unidown need to get in there.
They
Be a
do.
real step
It
forward.
needs to get to the point. Uni Down, especially, we just need to merge it. I think whatever state it's in by the end of Thursday, I might just merge it anyway, just
to
out of
do it.
spite. Just be like, ah!
Do it.
Just start fixing bugs on master instead because I've had enough.
Just do it now.
What did they say that? Like, fail often, right? Is that the...
Yeah, fail early, fail often.
Yeah.
Quite sure that was the phrase, but sure that works. Is Uni Down even passing? Does it even? It probably needs. It probably needs master merging into it again.
I think it does, yeah.
I'll do that.
Master is pretty far ahead now.
Do that right now.
Alright, anything else?
No.
I got nothing.
Oh.
Okie dokie. Till next week then.
Oh, Thursday.
By next week, I mean Thursday.
Yeah. It's like next week. It's like days away.
Thursday.